How do you cripple a $13 billion floating fortress? Imagine a city of steel, protected by the most sophisticated radar eyes on the planet, capable of tracking 1,000 incoming threats simultaneously. You'd think it would take a nuclear warhead or a swarm of supersonic missiles to even leave a scratch. But the answer is simpler and infinitely more terrifying. You don't use a hammer. We use a needle. A winged, screaming needle powered by the same engine you'd find in a common backyard lawnmower. We are talking about a $20,000 drone, literally less than the price of a basic sedan, taking on the apex predator of the high seas, a US Navy supercarrier. It sounds like a suicide mission. It sounds like a joke. But this is the new face of warfare in the Strait of Hormuz, and the punchline is deadly. This is the ultimate paradox of modern combat, a winged lawnmower versus a $13 billion Titan. Or, it's like trying to stop a swarm of bees with a sniper rifle. While the world stares at the horizon for high-altitude bombers, these compact monsters of plastic and composite are already hugging the waves at Mach 0.1, hiding in the literal shadows of the ocean swells. They are cheap, they are loud, and they are everywhere. But here is the terrifying part. Every single one of those drones represents a gamble that the defender cannot win. If a $1 million interceptor misses, the carrier dies. If the drone misses, you just launch another one for the price of a used car. It is a needle being driven into a massive steel bubble, waiting for the perfect moment to pop the illusion of invincibility. But that's just the beginning. To survive the wall of fire, this drone has to do something brilliant. It has to become a ghost. This is stage 1, the departure. It doesn't begin in a high-tech silo or a fortified bunker. Instead, the journey of this compact monster starts on the back of a nondescript, beat-up commercial truck parked on a dusty shoulder somewhere in the Iranian desert. To anyone passing by, it's just cargo. But inside the belly of that metal shell, a predator is waking up. This is the moment of the silent goodbye. There is no mission control counting down, no grand ceremony. Just a pneumatic rail and a single violent push. Explosive bolts aren't needed here. Just the raw thrust of a rocket booster that kicks the drone into the sky like a stone fired from a slingshot. Within seconds, the booster falls away, tumbling back to the dirt like a spent shell casing, and the drone is suddenly, utterly alone. Now the mission belongs to the machine. It is a small, sturdy triangle of composite and plastic facing the vastness of the coming storm. It has no pilot to breathe, no life support to fail, and no radio to call for help. It is just a primitive 30-pound brain of silicon and copper guiding a $20,000 airframe across hundreds of miles of hostile territory. Think about the isolation. Every kilometer it travels, it moves further away from the hand that launched it, venturing into a world where every radar dish and every Patriot battery is screaming its name. But it doesn't care. It can't feel the weight of the mission. It only knows the path. For the next several hours, this ghost in the machine will navigate by the stars and the digital maps burned into its memory, a solitary hunter in a sky filled with enemies. It is the ultimate suicide mission, a one-way ticket into the heart of the most defended airspace on Earth. And as the base fades into the horizon, the drone enters the most dangerous phase of its short life. Now the silence begins. This is stage 2, the electronic blackout. At barely 100 feet above the ground, the drone is screaming across the terrain at 100 miles per hour. This isn't just flying. It's a desperate, high-stakes game of hide-and-seek with physics. It hits the air so low that it literally hugs the contours of the Earth, dipping into valleys and skimming over ridgelines like a bird of prey. To put that in perspective, while a commercial jet cruises at 30,000 feet, this plastic monster is flying so low that it's practically dodging power lines and trees. This is where the magic of the ghost happens. Because it is built from carbon fiber and cheap composites, radar beams don't bounce off it. They get lost. They scatter. The drone doesn't have the massive metal silhouette of an F-35. It has the radar signature of a large bird or a low-flying cloud. It hits the wall of detection so softly that the gasping air defense systems simply cannot find it. Instead of a clear target, mission control rooms across the fleet see nothing but a blank, flickering telemetry screen. For several agonizing minutes, the world can only watch and wait while this fireball of intent rides through the blind spots of the most expensive sensors ever built. It is a total communications blackout, but not because of plasma or heat. It's a blackout of just. By staying low and staying quiet, the drone wraps itself in a cage of invisibility, cutting the defenders off from their own eyes. To survive the sheer violence of the modern battlefield, it does something brilliant. It disappears. It uses the very shape of the Earth to generate a shadow, bouncing its path off the terrain like a stone skipping across a pond to avoid the lethal plunge of a surface-to-air missile. During the approach, parts of the airframe might vibrate under the pressure, the cheap engine screaming at max RPM, but the drone remains steady. It is a lofted approach through the valleys, a gentler dip that allows the sensors to breathe without catching a glimpse of the threat. The roar of the engine is muffled by the sand dunes, and the voices of the interceptors crackle over empty frequencies. But wait, they are still miles from the target. The most dangerous part of the flight is yet to come. Any miscalculation, any sudden gust of wind, and this plastic monster will break apart against the desert floor. With the target finally in sight, it's time to stop flying and start falling. The most terrifying silence isn't the absence of sound, it's the moment before the impact. For the defenders, the fire hasn't died down. It hasn't even begun. And as the drone stabilizes its tumble into a vertical position, the world realizes that this ghost is very, very real. Just a reminder, this isn't a test flight. This is the main event. In the final seconds, the onboard software adjusts its roll one last time, ensuring it hits the target at the perfect angle to ensure total destruction. But how did all of this start? To understand the end, we have to look at the beginning. How does a machine this cheap beat a system this advanced? The answer is hidden in the physics of failure. To understand why the world's most powerful militaries are currently scratching their heads, we have to look under the plastic skin of this winged lawnmower. This is stage 3, the engineering of the underdog. First, let's talk about the heart of the beast. Most modern missiles use high-performance jet engines or solid rocket fuel. They are hot, they are fast, and they glow like a neon sign on an infrared camera. But the Shahed uses something embarrassingly simple, a 4-cylinder, 2-stroke engine. It's essentially the same motor you'd find on a high-end moat. Or, yes, a commercial lawnmower. It's loud, it's vibrating, and it's slow. But in the world of electronic warfare, slow and cool is a superpower. Because the engine doesn't produce a massive heat plume, heat-seeking missiles struggle to lock onto it. It's like trying to find a candle in a forest fire. To put that in perspective, while a jet fighter emits enough thermal energy to be seen from space, this drone emits just enough to be mistaken for a small generator. It's a tactical ghost. Then there is the geometry. Orion used its cone shape to generate lift and skip across the atmosphere. The Shahed uses its delta wing triangle shape to skip across radar waves. Every angle of its V shape is calculated to reflect radar pulses away from the source rather than back to it. It hits the air so low that it merges with the background noise of the Earth itself. Trees, cars, buildings. By the time a billion-dollar radar system realizes that cloud on the screen is actually a 20-kilogram warhead, it's often too late. But wait, there is a deeper layer to this brilliant simplicity. This is stage 4. To survive the sheer violence of modern defense, Iran didn't look for a better shield. They looked for a cheaper way to die. And this brings us to the twist. How does this actually stack up against the peak of American technology? Meet the Switchblade. It is the gold standard of US drone tech. It's a scalpel. It's whisper quiet, incredibly precise, and packed with sensors that can identify a specific person in a crowd from a mile away. It is a masterpiece of engineering, but it is also incredibly expensive and difficult to produce in mass. The US builds Ferraris, Iran builds 10,000 disposable bicycles. And here is where the math becomes cruel. This is the value that mission control rooms are terrified to calculate. To stop a single $20,000 drone, you often have to fire a Patriot missile that costs between $2 and $4 million. Just do the math. Every time a defender pulls the trigger and successfully shoots down a Shahed, they are essentially losing the economic war. It's like using a diamond-encrusted hammer to kill a common housefly. If you shoot it down, you lose millions. If you miss, you lose a power plant, a radar dish, or a ship. This is the blackout of the modern era. Not a loss of radio signal, but a total breakdown of the traditional cost-benefit ratio of war. It is the arithmetic of attrition. In a lofted approach of dozens or even hundreds of these drones, the goal isn't just to hit a target. The goal is to force the defender to run out of bullets. Because while the US and its allies are counting their precision-guided munitions, Iran is counting their lawnmower engines. Instead of a steep, lethal plunge of a single high-tech missile, the drone swarm uses its numbers to generate lift for the mission, bouncing off the defenses until the magazines are empty. During recent tests, even the most advanced heat shields and kinetic interceptors began to chip away under the sheer pressure of the numbers. So, how do they protect a fleet from a swarm? They don't just need better technology, they need a new path. This gentler approach to warfare, using low-cost, high-volume junk to paralyze gold, is a tactical skip that no one saw coming. It allows the attacker to breathe and vent the defender's resources without ever needing a major technical breakthrough. happy it keeps the G-forces of the economy manageable for the attacker while crushing the defender under the weight of their own expensive success. With the speed finally manageable and the target saturated, it's time to stop flying and start falling. But as the fire of the drone's engine finally fades into a subsonic whistle, the voices of the defenders crackle back over the radio with a terrifying realization. They are still at the most dangerous part of the engagement. Any miscalculation in the math of death will break the defense apart. It's time for the final act. The journey from a desert truck to a high-value target is almost complete. But how does this actually end? For that, we have to look at the moment the silence is broken. The roar of the plasma-like explosion is only seconds away. The journey ends with a splash or a blast, but even the final seconds are calculated. The onboard software, thrumming with the vibration of that two-stroke engine, adjusts the roll one last time, ensuring it hits the Pacific swells or the desert bunker at the perfect angle to protect the mission's goal from the impact. But how did all of this start? This was step 1, the end of the age of the invulnerable Titan. The journey of the winged lawnmower is a reminder that in the vastness of the coming storm, it isn't always the biggest or the fastest that survives. Sometimes it's the one that is simply too cheap to fail. Now, the journey coasts back to the reality of the front line. The return to the target is arguably the most dangerous part of the entire mission. Right before hitting the target, the illusion of safety is thrown away, leaving only the gumdrop-shaped warhead to do its work. The drone slams into the thick air of the defense zone at 100 miles per hour. That is slow. But if you're not careful, at that same speed, you will also be hit by the reality of a new world. So, take your strategic perspective back to the board. Because in this fire in the sky, it isn't just the drones that are burning, it's the old rules of war. Just as the nose cover of the old era blows off, we are left staring at the raw, vertical position of the future. This is not a drill, this is the main event. And just like that, the journey home is marked by a successful completion of a mission that no one thought could ever work. We make these videos from scratch, animated by humans, to help you see the ghosts in the machine before they arrive. The drone is now just feet from the target. That subsonic whistle of the tiny engine is the last thing anyone hears. This is the moment where Stage 1 meets Stage 6. It's not just the end of a $20,000 flight, it's the beginning of a terrifying new reality in global security. We are no longer watching a test flight, we are watching a paradigm shift. Is this just propaganda? No. This is a cold, independent deep dive grounded in the brutal physics of attrition. Every number we've discussed, the cost of the engine, the radar signature of the composite wings, the merciless math of the interceptor gap, is a technical fact of the world we now live in. We don't just tell stories, we dissect the systems that move the world. So, as the dust settles and the telemetry screens go dark, I have to ask, what happens to the billion-dollar fleet when the bullets finally run out? In a world where the hunter is cheaper than the target, who really owns the sky? Think about it. The future of warfare isn't just about who has the biggest engine, it's about who can afford to lose. We make these original videos from scratch, researched by experts and animated by humans to give you a front row seat to the wonders and the warnings of the modern age. Successful completion.